Hi, this is Alec from Infinite Ammo, Winnipeg, Canada, and this is part 2 of the Unity tutorial series. We're going to be talking about how to make a little 2D side-scrolling space shooter called Schpooter, which may be a swear word in German, I don't know, I haven't looked it up. So this is the game. It's really simple. Enemies come from the right side of the screen, you can shoot them or spoot them, and you can die. Now you can go and download the project file from the Infinite Ammo website at this URL. And once you've opened it, come back because we're going to look through it. So now we're in the project file. But before we look at that, I want to talk about an idea that's kind of important for game programming. So bear with me for a minute. The idea I want to talk about is called encapsulation. And that's kind of a big word, but what it means is just basically putting things in boxes. It means putting things in a box and you can't really tell what it is, but you know that it does something. So say for example your computer, it's kind of in a box, you don't know how all the different components work, but you can use it to perform certain functions. This is really important in game programming because you're going to be building systems that need to communicate with each other without knowing too much about how they work. If they know too much about how the other systems work and you change those other systems, you're going to have to go change everything. That's something that we call dependencies. Basically, if an object is dependent on knowing something about another system and you change that system, then you're going to have to change the original system trying to get the information. So what encapsulation does is basically let you keep those systems separate so that they don't need to know everything about each other. We're going to see a few examples of how to do that in Unity today. So in this project file here we have a bunch of different folders and we've divided everything into different categories. This is really important to keep your project organized, especially if it's going to grow into a much larger project. You need to keep it organized, otherwise it's going to get crazy. So these are materials, and materials are what we apply to different 3D objects to give them color and tint and texture. This is one that's used for the enemy ship, and you can see it has a ship texture on it, and it's also been tinted red. You could change this color if you want. This is the image that's attached to it. It's in the textures folder. You could just click it to see it get highlighted here. How was this file imported? It was just dragged into the project file. You can even open up the folder here and just see that it's just a BMP file. That's all that it is. Now here's the models folder. In this model we actually found, I grabbed it from the assembly competition over at TigSource. This is a competition that's kind of interesting because it's in two phases. The first phase, people just make a bunch of different art assets and sound assets. So this is a really neat place to go to find stuff for prototyping if you want to find some models and stuff to just throw together into a game. And there's some really great 2D art. This is like little pieces of a mech game. There's just lots of really neat stuff in here. The second part of the competition is going to be putting those assets together into finalized games. So if you're interested in that, check it out. We just stole this one model. And same thing for importing models. All you need to do is just drag them into the project folder. If they are a supported model format, they will import fine. If not, there will be problems. You can adjust various settings here, which we don't really have to do because we're happy with how our model looks right now. And if you're going to do skeletal animation later, you're going to need to play around with these animation options, but for now we're not worried about that. Prefabs folder, we talked last time that prefabs are basically blueprints for creating objects. So these are different reusable blueprints that we have. We have a messenger object, we have an explosion object for the enemy, we have an explosion object for the player, a ship for the enemy, a ship for the player, and a shot. We have scenes folder. There's only one scene, it's just the game. If we wanted to create, say, a title screen, we might create a separate scene for that. This is our scripts folder. We have 3 different folders in here. One for the game, one for library, which is basically a bunch of reusable scripts that we can use in different projects, not necessarily just shooters or Schpooters, as the case may be. And this is the messages folder for various messages that we are going to be sending, and that ties in with what we were saying before about encapsulation and keeping systems separate. These are in the games folder we have the scripts that are directly related to the game. And some of these are actually kind of reusable. We'll look at those later. We have a sounds folder where we have different sound effects that we've created for the game. These are created using CFXer, which is a really cool program. And I'll give you a link to that. You should check it out. And let's look at the scene here, how the scene hierarchy is set up. Let's start at the top and just go down. We have a HUD, and this just deals with showing the retry button that shows up when you die. We have the messenger, which handles sending messages between different objects. This was written by Flashbang Studios. It's a really cool reusable component. Score, which is this visible text score here. It has its own script that manages displaying that. We have the camera. Without that, we wouldn't be able to see anything. And this particle system here is actually the star field in the background. The ship isn't actually flying through simulated space or anything like that. We're just shooting stars past it to make it look like it's moving. And we have a point light here, and that just sort of makes the scene look less boring. The ship player object that we talked about before. And let's look at how this is built. We're doing something here called parenting. Now we have this is the parent object here in the hierarchy. You can see how this one is kind of nested underneath it. I'm just going to explain parenting very briefly here by creating two objects. I'm going to create a cube, and I'm going to create a sphere. And I'm going to parent the sphere to the cube. So to do that, in the hierarchy view here, I'm just going to drag sphere up to cube, and you'll see the cursor changes into a different type. I let go. Now there's this little folder icon, and the sphere is parented to the cube, which is a way of saying the sphere is now a child of the cube. So if I move the cube around, I can see that the sphere moves with it because now it's attached to it in a way. But I can still move the sphere within that space. But that movement is relative to the frame of reference of the cube. So that's just a little blurb about parenting there, and why we're using it here is more just so we can simplify things. We can have this top layer have all our scripts and our collider and our rigid body and our audio source, and underneath we have the model as its own separate thing, and we also have this particle exhaust, and we could add other things in here too if we wanted to. But the reason we're using parenting in this case is just to simplify the organization of it. We can hide that stuff if we don't want to see it. It's nice. This is called sides, and this is an empty that has two cubes as children, and these cubes are invisible, but the player will collide with them, and this just stops the player from going out of bounds. The player is actually using physics to move, and that's why we need these little things to block it. Spawner is a little empty object here that has a spawner script attached to it, and it's what spawns the enemies. And you can see it has a prefab link to it for the enemy and the amount of time that things spawn at. So it's kind of just a brief overview of the things in the scene, and we're going to talk about next how the scripts actually work. So see you in the next part.